Hello everyone, welcome back to Comp 232. Today's lecture is about the linked list data structure. Before I start with linked list, I want to inform you that there are two assignments. I have already put one on the queues data structure, the one that's asking you to do a circular array. I will make it, since nobody sent me any email regarding this assignment, I'm going to put it on Moodle, post on Moodle along with another assignment which asks you to implement queues using two pointers, pointer to front and pointer to rear, okay? So I'll make sure these two assignments are put on Moodle. You have to work on those this week. Now, you will hand it in using Moodle. So linked lists. What are linked lists? You're going to, as the name indicates, a linked list is a list of items that are linked together. So you have a list of items. When I say the word list, most of you would remember arrays. Arrays was a list of items that are they're linked together or they're put sequentially after each other. And linked lists is the same as queues and stack in the way that each element is connected to the next element, the successor element and the one before it, using pointers. So linked lists are list items that are linked together using pointers, and we said that's possible, okay, because we have to use pointers because the elements are not stored sequentially. So each element is linked to the other element using pointers. So having talked about stacks and queues, one question would be, how can I add to this list? You can add anywhere in a linked list. So unlike queues and stacks, in linked lists, we can add items anywhere in the list. We should do the appropriate arrangement of pointers. So we should be fixing pointers in order to add or push an element into the linked list anywhere in the linked list. So is the remove. We remove an element from the linked list from any index. So we have indexes in linked lists, or let's say, we have positions of the elements, which one is first, second, third. But, however, unlike arrays, they are not stored sequentially. However, the first element, all right, is linked to the second element by a pointer. So I want this to be clear that the elements of a linked list are not sequential. However, they have, we refer to them by an index. We can know the first, the second, the third element, but not sequentially, but with pointers, as we shall see in the following slides. So let me actually do that. So how would we implement a numeric list? We want to add an element at the kth position. So we can add an element anywhere in the linked list at any position. So these are the functions that we are going to be implementing. We can add an element at the beginning of the list as well as at the end of the list. So we can add an element anywhere in the list, at the beginning, at the end, or in the kth position. We remove an element from the kth position, as well as we can remove an element from the beginning, and we can remove an element from the end of the list. We can only change the value of the element at the kth position. We can change an element value at the beginning of the list, and we can change the element value at the end of the list. Finally, we can print all the elements of the list, okay, and we can display the value of an element at the kth position, so we want to see what element we have at any position. In order to implement a numeric linked list, let's look at this example together. Again, you are all asked to actually write this down in C and run the code. So like we did before in stacks and queues, in linked list we have a different naming. It could have been also item, but here we call it node. Okay. So we defined a new structure called node, and this new structure, like new item that we talked about before that we used in queues and stacks, it also has two elements. A number, which is an integer, because it's a numeric linked list, it could have been a different thing, and a pointer to another node. So pointer, node star, which is a pointer to a node, and we're going to name it pNext node. Okay? So we start by creating a new node the same way we did create a new item in stacks and queues. We give it the integer, okay? And in the first line, we allocate using malloc the size of node, okay? And we give it to new node, and that's the pointer to the new element that I'm creating. And this new element, so new node, this is the pointer. Instead of putting dot, we put arrow because it's a pointer. So new node dot number is equal to new number, new node dot pNext node is equal to null. So we initialize the pointer to be equal to null, and we return this pointer, which is a new node. So new node, we allocate using malloc size of node. We set the number equal to this new number that we pass to it, and the pointer to null, and we return the pointer. This is the same as the structure that we saw earlier. Freeing a node, we said when we use malloc, we have to use the free keyword. So free pnode, it will free whatever pnode was pointing to. Okay? And use the keyword delete to free the removed node from memory. So what I was talking at the beginning of the lecture is actually shown here in this graph. As you can see, I have list of elements. Let's say we're indexing them 0, node 1, node 2, and node 3, okay? And they're not sequential. Instead of being sequential in memory, what we have is a pointer. So node 1 should point to node 2, node 2 should point to node 3, etc. In this example, we have the beginning node is node 1 and the last node is node 3. So we have 3 nodes. What's nice about this implementation is that we start with a node 0. This node 0 is going to have the count. How many nodes do I have in the linked list? So what's nice about the implementation is that the first node, node 0, will have the count, the number of nodes in the linked list, as well as pointer to first element, which is node 1. As we know, in queues and stacks, we always define them as the pointer to first element. So the same case here, node 0 will define my linked list. If I have node 0, I have everything. So node 0 is the pointer to first element, as well as we added a new thing here, which is the count or the number of nodes in the linked list. So let's say we want to add a new node. I can specify, as I said before, we can, as we said at the beginning, the steps that we're going to do is that we're going to add an element at the kth position, at any position, or at the beginning or at the end. So let's see how to implement those. So in here, we start with adding an element at any position. In this example, I want to add a new node which contains number 6 at the position 2. So to do that, at position 2, so you should assume that it's going to be inserted, it's going to be the second, it's going to be inserted at node 2. So node 2 will become node 3. So this is going to be fit in here, all right? To do that, first of all, the pointer of the new node, so if I'm going to add it at position 2, the pointer should point at node 2. It's as easy as this. So I have to get to node 2. Okay, so this is a pointer to node 2. Now the new pointer, so we can memorize it like this, or we can remember it like this. Because I'm adding the element at position 2, the pointer is going to point at 2. At 2. Okay, so for this pointer to point at node 2, it has to be set equal to this pointer. Because which pointer is pointing to node 2? The pointer of node 1. So the pointer of node 1, which is pointing to node 2, I'm going to give this value to the pointer of the new item. So the new item and node 1, both of them are pointing to node 2. Now node 1's pointer should point to what now? For those who said that it should point to the new node, that's correct. So this pointer here should be, after using it here, so we copied its value here. Now the new node is pointing to node 2 because I'm adding it at position 2. The node before it, the pointer before it, should point now to the new item. And in this case, I have added this new node. It's now added at position 2, and position 2 will become 3, and position 3 will become 4. And one more thing that I have to update is the count, or the number of elements of this linked list will become increased by 1. So let's see these 3 steps, how we're going to do them in C. So the 3 steps are, you have to copy this node. So the pointer of the new node is equal to the pointer that was pointing to node 1, which is this one. And pointer of node 1 will be pointing to the new node, and we have to increment the count of elements in the linked list. Sounds good. So let's see how to add an element at the kth position using C. The function name is add node. When we add a node, we don't have to return anything, and that's why it's void. Node star, so this is P first node, so we always indicate the linked list by pointer to first element. So this is the pointer to first element, node star P first node. So this is the first pointer to the first element in the linked list. Node start P new node, this is node star, this is then pointer to the new node, and this is the position at which I want to add new node. So to start with, what do we do first? Let me use a pen here. So the first step is that how do I get to this position? Let's say position 2. How do I get to a position 2? We're using arrays. It was straightforward. It's done immediately. We add 2 to the name of the array because it's a pointer to the first element. That's not possible here. And here, like in other data structures, we have to go through them node by node because they're not sequential. So I cannot get to the position right away. They're not stored sequentially, so I have to go node by node looking at the pointer until I get to this position. So PTR is equal to P first node, so it's pointing to the first node. Okay. Now for I equal 1, okay, so we're pointing at the first element. I less than position I plus plus. Pointer is equal to pointer dot P next node in order to go until we reach to position. How did I reach to position? Is it less than or equal position, or is it less than position? So less than position, which means if position was 2, this pointer, okay, will be pointing to next item. So this one is pointing to the element at 2. So this pointer, so we stop when the pointer is pointing to the position, the element at this position. That's why we stop an element before it, because the element before it, the pointer before it is pointing to that in this position. So we stop at strictly less than position so that I have the pointer pointing at the element at position, okay? In this case, in our example, at 2. So this would stop at 1. If position is less than or equal P first node dot number, which means that what's P first node? p first node dot number, which is the size. So this is the size, where the size of your linked list is stored. So this is the size. Okay, so if position is less than the size, then p new node dot p next node is equal to pointer dot p next node. So what does this mean? It's less than or equal, which means that it's not, so it's within, it's not a new item, it's not at the end. Okay, so it's less than or equal, which means it's within, yes, it's within the linked list. It's not added after that. So if I have 3, so 1, 2, 3, it's within. So it's 1, it's at position 1, or 2 and 3. It's not at position 4. If I was to be adding at the end, then it would be at position 4. So if position is less than the size, which is within, yes, within the linked list, then p new node dot p next node is equal to pointer dot p next node, and that's the first step. So the first step is that I set the pointer of the new node equal to the pointer dot p next node, which is the same one as this one, which were both pointing to position 2 if position was 2. Okay, so now I have new node and pointer, they're both pointing to position 2. So now my new node, the most important thing is that new node is now pointing to position 2. Now I'm going to set pointer dot p next node, the one before it, the one that was pointing to 2, which is node 1, let's say. So node 1, it's equal to p new node. I'm setting the pointer of the node before it, because this was PTR was pointing to node 2. Now PTR, I want it to point to p new node. So as if p new node now is node 2, and p new node is pointing to node 2, which is going to be node 3, like the graphical, how we did it graphically. P first node dot number plus plus, which means incremented by 1. So now the size is incremented by 1. So this is exactly the 3 steps that we talked about. Okay, but before we applied these 3 steps, those 3 steps, what we did first was this one. So let's put it all together. We did the 3 steps. We set the pointer of the new node to the pointer at 2 to 2. We set the pointer of the one that was pointing to 2 becomes pointing to the new node, and we increment the size. But before we do that, we have to set a pointer that goes from 1 to the position before 2, which is 1. So we have to go through the linked list using a for loop, because we cannot get to a certain position right away. We have to go through all the elements in order to get to the position. Okay, so please write it down and run it. We will run a main on it later on at the end of the lecture. So these are the 3 steps that we should do. But before we do the 3 steps, we have to move the pointer to the position right before, to the element right before position, because it's strictly less than position. Okay, why? Because at this position, just before, at the node just before position, will be the node pointing to next node. Okay, to position 2. So adding an element at the beginning of the list, we use the last function, the function we thought, but we add an element at the kth position. Instead of being the kth position, we want to set the position to 1. So we remove the position here. So we have removed the position that we added here, that was here. And instead of that, we put 1. So we use the same function, add node. That's the same function we implemented. But now instead of position, we put 1 here. Okay, so the position was 1. All right, and in this case, pointer will, it's already pointing, so pointer, is it less than 1? So pointer is already pointing to the first element, and we do these 3 steps. Okay, so we don't have to move through the array, through the linked list, because we are already pointing to the first element. So this is pointing to ptr is equal to ptr.pnext node, which is pointing to this element. All right, to the element at which I want to move, which is the first element. So this is the point, this is pointing to the first node. Okay, and that's where I'm going to insert my new node. I wonder whether this is, please write in your comments whether you find this easy or hard. If you find it hard, we can have more elaboration on it if you didn't grasp it very well. Okay, so pointer now is pointing to the first element, and that's where I'm going to insert my new item. And to insert it, I make the new item pointer the same as this one. So now the new item and ptr, they are both, like we said before, but now they are both pointing to the first element, the element at position 1. Okay, after that, I will make the one at position 1 to point to, so pointer.pnext node is now pointing to new node. So this is the pointer that I had before, is now pointing to the new node. That's node 0, that is now pointing to the new node, and new node is pointing to, new node is now pointing to node 1. Okay, so new node will become 1, and this will become 2. So this will become 2, position 2, and new node is the position 1. This will become at position 1, and this is ptr of the one before it is now pointing to p new node, which is at position 1, and this is position 0. I think this elaboration should make you understand it very well. So now the one before the pointer is now at 0, the new node is at 1, and the one that was at 1 is now at 2. And the final step is to increment the size by 1. So this was add node at the first position. So adding an element at the end of the list, instead of adding it at position, now we're going to add it at pfirstNode.number plus 1. In our example, pfirstNode.number, which is the size of the list, was 3. So I want to add it at position 4. So the new item is going to be at position 4. We do that using the same function add node. So let's see how it's done. So add node where the position is equal to 4. So here you have 4, which is the n. This is one element more than the number of elements. So it's outside, it's another element added to the list. Okay? So again, we start with the pointer to the first item, the first node, and we start moving the pointer until we reach position I less than position, which is 3. Okay, and position was 4. So at position 3, the pointer of the third node, okay, is pointing to, this pointer is equal. So now this pointer, ptr, is pointing to null, which is, this is the pointer of the last element in the list. This if is not valid anymore. So this if, we said before that this if position, in this example, the position was 4, is less than or equal the number of elements. So this is not applicable anymore. So one step is removed because we're adding to a new item at the end of the list. So this step is removed. Okay, we don't go to the if, we immediately go to this element here, making the pointer, which was pointing to null. This is the pointer of the third element, the last element. So the pointer of the last element, element 3 in our example, which was pointing to null, is now pointing to new node. Okay, so the last element, node 3, is now pointing to new node. So new node is now at position 4, and this is the pointer of the third element. So the pointer of the third element is now pointing to new node. How did we get to the third element? Using this for loop. We go through the for loop till we get to the pointer of the third element, and we set this pointer, okay, this pointer that's inside the third element, we make it pointing to new node, and we increment the size by 1, which was 3. Now the size is 4, and having the size 4, this means the last element is at position 4, and we didn't change the pointer of the last element, which means that the last element is still pointing to null. We'll continue next time with removing elements from the linked list.